Right. So now we're going to review combining like terms. Now, like terms have the same base raised to the same exponent. And the whole point of combining like terms is for adding and subtracting problems. So if you're looking right here, circle the like terms. I've got 12x squared, 3x squared, and negative 2x squared. All of those have x to the second power, so that's why they are like terms. So look at examples number 1 and 2. On one of these, I have you adding these two terms. On the other one, I've got you multiplying them. Now, when you're combining like terms, think of this as saying I've got 3 apples plus 5 apples. That means I have 8 apples. I didn't change the apples at all. So that's why when you combine like terms, you only change the coefficient, the big number out in front. 3 plus 5, that's how I got the 8. But when you are multiplying two of those terms together, that is a different story. That one changes both. When I multiply 3 times 5, that gives me 15. And when I've got x cubed being multiplied by another x cubed, that ends up giving me x to the 6th power. And at this point, you are now allowed to add 3 plus 3 to get 6 instead of expanding it if you don't need to. Okay, so let's look at that kind of problem again. When you are adding them, negative 2a plus 10a, you are just adding or subtracting the numbers in front, the big coefficients. So negative 2 plus 10 gives me a positive 8, which means this one is 8a. But on example number 4, that one's multiplying. I multiply the coefficients. Negative 2 times 10 gives me negative 20. And then I multiply the variables. Well, a times a gives me a squared because there was 2 of them being multiplied together. All right, so continuing this same trend. Both of these have y to the 4th power, so they are like terms, which means that I can combine them. So 15 minus 3 gives me 12, y to the 4th. So when you add or subtract, you do not change the exponents. Now, since there's nothing between 15y to the 4th and that set of parentheses, that makes this a multiplication problem. So I'm going to multiply 15 times negative 3. That gives me a negative 45. And then when I multiply y to the 4th times y to the 4th, that means that I have y to the 8th power. So you do change the exponents when you multiply. Look down at example number 7. I've got x to the 8th power and x cubed. Now, guys, these two things are not like terms. They do not have the same letter raised to the same exponent, so we cannot combine them. I can't do anything else to that problem. It's just staying the same. But when you look at example number 8, it does not matter when you're multiplying two terms if they have the same exponents. So I can still multiply 7 and 4 and get 28. X to the 8th power and x cubed altogether gives me x to the 11th power. I just add their exponents. So let's get a little bit of practice doing some combining like terms problems since it's been a while. When you are working these problems, find the letters that they have in common, the like terms. These two both had a regular A, so I'm going to put boxes around them. When you do that, make sure that you take whatever sign is in front of it. So now I know when I'm combining them, what I'm doing is the problem 5a minus 3a. So that ends up giving me a positive 2a. For the B's, I'm going to make sure that I take their signs in front of them. That's positive 8b and negative 12b. So what I'm going to type in is 8 minus 12. Notice that I'm saying minus, not a negative. That gives me negative 4, so that means I've got minus 4b. Look back up at example number 10. I've got to find my like terms. Well, I've got an x squared here and another x squared here. Notice that I took the sign in front of it. So when I combine those, 17 minus 3 gives me a positive 14. So 14x squared. The other guy, I just move him right on down. And number 11, a slightly longer combining like terms problem. I've got a like term here and one here. So I'm going to go ahead and use my calculator to type that in. Since this is the very beginning of the problem, I do need to use a negative sign. So negative 3 plus 14 ends up giving me a positive 11. That means I have 11x squareds. Then I'm going to combine my positive 10 with my positive 8. Those two things are both constants, so when I add them, I get a regular 18. Now, don't forget about this negative 5x. It does need to move down, even though it couldn't be combined with anybody. So the last type of problems that we need to deal with are dividing terms. When you've got 1, 2, 3 terms all being divided by 2, you need to divide those each separately. So I'm going to separate it every time there's a plus or a minus sign. I've got a 10x, I've got a positive 16y, and I've got a negative 4z. So I'm just putting a little bit of space between each one on that top row. So each one of those things I am going to divide by 2. And when I do that, I can put them back together. 10 divided by 2 gives me 5x. 16 divided by 2 gives me a positive 8y. And negative 4 divided by 2 gives me negative 2z. And that's all I need to do. So let's look at that same type of problem on example 3. I've got 2 terms here. So I've got a negative 16x and a negative 28y. So I'm just separating them. Divide each side by 4. So let's go ahead and say negative divided by a positive gives me a negative 4x. And negative divided by a positive right here gives me negative 7y. Last one like that, I've got 14x squared and a negative 7y cubed. Each one of those needs to be divided by that negative 1, which is just going to change their signs. 14 divided by a negative 1 is negative 14. Don't forget about the x squared. And double negatives right here give me a positive 7y cubed.